Hello, my name is Chisholm Craig. I'm the manager of the Learning Center in Scott, Mississippi, and I'm going to talk to you today about corn hybrids, plant populations, and row spacing. I'm standing in front of a trial that we've had for 2 years now in the Mississippi area, and we're looking at how different hybrids respond to plant populations and row configurations. Primarily, how do those hybrids respond to single row configurations compared to a twin row configuration. This is the second year of the study. Last year we had some very interesting results and saw yields plateau at about 36,000 final stand, and so we repeated the study this year to see if that held true in both an irrigated and a non-irrigated environment. We've got 4 hybrids that we're looking at, ranging from 113-day relative maturity to 119-day relative maturity. We have those at populations of 28,000, 32,000, 36,000, and 40,000 seed per acre. We also have those in a single row configuration as well as a twin row configuration. And we have it in an irrigated setting as well as a dryland setting. Now, what I'm standing in front of today is a twin row configuration, and one of the things that we saw last year that gave the twin row corn an advantage was that we were able to simulate a 30-inch row spacing on a 38-inch bed. Now, here in the Mississippi Delta, we grow most of our crops on a wide 38 or 40-inch bed to facilitate 2 things. One is surface drainage of water, and also to aid in furrow irrigation. 30-inch rows have been tried in the past, but unfortunately, because of our drainage situation and the need to place these corn and soybean varieties on beds, we returned to the 38-inch system that we were traditionally using with cotton. Now, we know that the 30-inch system has an advantage over the wide row 38 system because of the ability to spread plants out on a single row. With the twin row system, we're able to spread those plants out like we would on a 30-inch row while still utilizing the 38-inch bed. So here, for example, I'm standing in front of a seeding rate of 36,000. On a traditional 38-inch bed, these plants would be spaced approximately 4 inches apart. Therefore, you've got plants that are competing for space, light, nutrients, and water a lot more aggressively than if those plants were spaced 7 or 8 inches apart. With the twin row system, we're able to space these 7.5 to 8 inches apart and maintain what we call a diamond pattern. For example, we're able to stagger these plants and therefore better utilize not only the soil and water but also light as it comes down from above. Now, last year with this system, we saw a 13% advantage to the twin row over single row system. This study was planted on March the 24th of this year using a single row planter and a twin row planter. Now, to give you an idea, our traditional system here in the Mid-South is using a single 38-inch planter or a single row planted on top of a 38-inch bed. As you can see, we have one drill down the center of the 38-inch bed. And as we talked about before, the spacing of these plants is a little bit crowded due to the number of plants we're trying to get on that single bed. But if you compare it to a twin row system where we have 2 single drills that are spaced 7.5 inches apart, we're able to utilize the same 38-inch bed, but because we have 2 different rows on top of one bed, we're able to spread those seed out on top of the bed, therefore giving us a much better interplant spacing. And we've seen through previous research that population has shown to increase yield, but one of the most important things to remember while increasing seeding rates is to maintain adequate spacing between plants to allow for better light interception, utilization of soil, nutrients, and water. Okay, one of the things that we're constantly asked is we talk to our customers about plant population. The ones that increase their plant populations and are shooting for those high years, the first year that they actually have that higher population, one of the calls that we get is about ear size. And especially when we've had producers that start at 28,000 and they move their plant population up to 36 or 37,000. And one of the things that we get is, why are my ears so small? Well, there are a lot of factors that contribute to ear size. Genetics could be one, plant stress could be one, but population also contributes to ear size. For example, we have an ear here that was planted at, or that came from a plot that was planted at 28,000. This is a very good looking ear. It's large, it's filled out all the way to the end. It's got 16 around, it's 36 long, and I think it's going to be really high yielding corn. But there are only 28,000 of these. On the other hand, this is an ear that came from the same hybrid that was planted at 40,000, and we have a final stand of about 38,000 plants per acre. Now this is a much smaller ear, and this would probably cause some concern among producers. But one of the things that we have to remind them is that this is still 16 around, and although it's only 30 long, there are 12,000 more of these ears than this, and 6 or 7 more kernels, or even 2 more rows around. It's very difficult for that to make up for 12,000 more ears per acre. And so one of the things that we encourage producers to do is, before making any judgment about increasing plant populations, wait till the yields come in and then determine if that plant population was the correct population for your farm and the hybrid that you selected. Again, many factors influence ear size. We can have drought, we can have nutrient deficiency, and to some extent hybrids or genetics. But again, as you increase your plant population, it's not uncommon to see ear size become a little smaller and to see a little bit of a tip back. I'm standing here in front of the irrigated portion of this trial. This trial has been managed for high yields. It does have 250 pounds of nitrogen, 30 pounds of phosphorus, and 120 pounds of potash, along with a pound of boron and 10 pounds of sulfur. Now the reason I mention this is not to talk about how much nitrogen or fertilizer that we apply, but to remind folks that as we increase these populations, as we push these yields beyond that 180 to 200 bushel range, we must fertilize adequately. For example, if our yield goal is 225 pounds per acre, we don't need to fertilize for their 150 and 165 bushel yield that we've been getting in the past. Because what happens if we fertilize too lightly and we irrigate correctly and we have a high yield potential because we've got a high yielding hybrid at a high yielding population, but we have inadequate fertility, then that plant begins to rob other sources for those nutrients, primarily the stalk. And when we see situations like that, where we have a very large ear and high yield potential, and we see that plant begin to rob the stalk in order to fill that ear, we run into situations where we have loss of intactness and potentially lodging. So I encourage you to match your correct fertility rate with the correct population for the hybrid that you intend to plant. In the previous footage, we were standing in front of the irrigated portion of the trial, but as you can tell looking behind me, this is the non-irrigated portion. Now, one of the ways you can tell it's non-irrigated is because you see a tremendous loss of intactness in these plants. We had an extremely dry summer, and although we fertilized this adequately for high yield, because of the dry conditions, that plant was not able to utilize all of the nutrients that we provided. And so as a result, you see the plant was beginning to rob these stalks in order to fill these ears. Therefore, we were left with a very brittle and unhealthy stalk, and we begin to see some of those plants break over and look a little suspect. We're not seeing a tremendous amount of lodging at this point. However, if left in the field to weather too long, we could expect to see some lodging in a situation like this.